All right. Welcome, welcome, welcome. So, we are back. We are still in this hybrid type model of things. Um, Before we start with the notes today, and I'll be honest with you, I think that this is my, um, I would say, second favorite pre-calc unit that we're going to start today. It's awesome. I love it. Okay, excited about it because it's all logic, and I'm one of those logical type people. Okay. Couple of things to make note about second semester. Live classes still Tuesday and Wednesday. Thank you guys for all joining in on the Tuesday class. Thursday, that's an optional day again. Okay. You can join in live if you're not at school, but we will post a video. Usually Wednesday afternoon, we'll post that video for about Thursday's class when we get going to it. Okay, so that you don't have to wait for me to post it after my classes because mine are kind of later on in the day. Okay? So live classes Tuesday and Wednesdays. We are second semester, and I'm sure that you're going to find out a lot about this too. We are the expectation now, second semester, we've been told we can now expect you to have your cameras on. Okay? And so we're going to kind of give you a little leeway this week with the cameras, but unless we have something on file through either a counselor, a case manager, or the main office, we expect your cameras to be on and you actively participating in it, okay, in class second semester. Grading phase is Wednesday, so whoever your teacher is tomorrow, that's your grading teacher. Those are your grading mods, the whatever mods you log into tomorrow. You know, there was a little confusion about that this last semester. Okay? And lastly, we'll have a quick formative quiz this week. It is 2 questions this week, okay? But it's not on its learning. It's because of, you'll see what we're doing today, it's not a multiple choice type thing. It's you got to show your work, show your steps, show your thought process to go through it. And so it's like a homework turn-in type one, where there's a problem in one of the boxes, and then you take a picture in that box of your work, then go to the next one, take a picture of your work. So that's for this weekend. So that will open up on probably Thursday after school-ish. I'll open it up, and then you'll have until Monday night to get it done. Okay? All right? Love it. So, new chapter. What do we have to look forward to now in this chapter? And by no means does anybody have to write this down, just so you know. This is just we can talk about it. But we're gonna shift instead of calculation, which is what we were doing in chapter 4. We were calculating trig values and finding trig values and that kind of a thing. Now we're gonna shift to theory and proof. Okay? Exploring some properties of special functions of trigs, leading us with no immediate concern for real world relevance. Okay, it's because we're all talking, we're going to be using formulas and properties and that kind of a thing. And so we went all Englishy on you. We hope in the process to give you an appreciation for the rich and intricate tapestry of interlocking patterns that can be woven from the 6 basic trig functions. Patterns that will take an even greater beauty later on when you can view them through the lens of calculus. Okay? Now, one thing that I will tell you is at some point in time during the first semester, you should have gotten this pink cardstock sheet of formulas. If you have that with you today and in this unit, it would be very beneficial for you to have that out at all times. Okay? That pink cardstock sheet with 26 different, it's got pre-calculus reference chart at the top. Just have that out kind of by the side because we're going to start going through some of those a little bit later on when we get through this stuff. Okay? So, Just a refresher of the 6 trig identities and the big one and the 7th big one. Okay? So cosine is cosine, sine is sine. Okay? We know those. Okay? But secant is the reciprocal of cosine, so secant is 1 over cosine. Tangent is sine over cosine. Cosecant is the reciprocal of sine, so that is 1 over sine. And cotangent is the reciprocal of tangent, which is cosine over sine. And then you got the big one, which is the hammer. Sine squared plus cosine squared is equal to 1. This is number 7 on the pink sheet. Okay? And then we have also on the pink sheet, we have it when it's equal to cosine. So cosine squared is 1 minus sine squared, and sine squared is 1 minus cosine squared. Okay? So that's number 7 there, that on the pink sheet. Okay? Now, what we want to do is we want to take the hammer there, and we want to manipulate it a little bit. So, first off, we start with the hammer. Sine squared plus cosine squared equals 1. Learned that very first day of trig. Okay? What happens to the hammer if we divide both sides by sine squared? Okay? So if I divide the left side by sine squared of theta, that means I really have to divide both of those terms by sine squared of theta. And if I'm doing that on the left side, well, then I got to do it on the right side. Okay? Love it? Okay? Well, let's do some math. Let's do some logic. Sine squared divided by sine squared. What you got? 1. Love it. 1. Cosine squared divided by sine squared. Not cotangent, it would be cotangent squared. Yep, so it would be cotangent squared. One divided by sine squared. Cosecant squared. And that, ladies and gentlemen, is another trig identity that you now have in your toolbox. We're going shopping at Harbor Freight, and we're getting new tools. Okay? Okay? This tool is number 10 on your pink sheet, I believe. Yes, it is. Cosecant squared is equal to 1 plus cotangent squared, which we could also rewrite as cotangent squared is cosecant squared minus 1. Okay, so we can tweak that around a little bit also. Okay? So that's number 10 on your pink sheet. Well, let's do the same thing, but instead, let's divide everything by cosine squared. Okay. Sine squared divided by cosine squared. Sine squared divided by cosine squared. Tangent squared. Cosine squared divided by cosine squared. 1. One divided by cosine squared. Secant squared. Hey, thanks, Mr. Rob. another tool in our toolbox. Okay? And that one is number 11. Okay? Which could also be tangent squared is equal to secant squared minus 1. Okay? So we can rewrite those tools and adjust them however we need. Okay? Now, where we're going to use all of those plus numbers 1 through 6, 8 and 9 we'll use a little bit, but we'll get to more of them later on, is we are going to ask you to simplify trigonometric expressions. Okay? Now what'd you forget? No. Uh-oh. Probably in the copy room. Okay? So utilizing our pink sheets, secant of the opposite of x, if I utilize number 4, okay? So secant of the opposite of x is really the secant of x, utilizing number 4 on our pink sheet. Cosine of negative x is cosine of x. Secant is 1 over cosine . One over cosine times cosine is 1. So secant of negative x times cosine of negative x is just 1. Okay? Now, is that the only way to do that particular problem? No, it is not. Okay? We could have also said that this is 1 over the it is secant already. This is 1 over the cosine of negative x times the cosine of negative x, and then we've got to 1 that way. Okay? It is not, or I don't want to say it's not up to you to decide. It is really up to you to decide how you do it. But it is not your burden to do it one particular way. Okay? You just have to logically show how you got to the next step, how you get to the end. Okay? You know what I mean? Okay? It is our job as your teachers to follow your logic and to make sure that it is logically sound. Okay? You just have to show your work. And the kicker here is you gotta show your work on this stuff. You can't just go, like here in this next one, the next one is also equal to 1. You can't just go to 1 without showing what you're thinking. Okay? Work definitely needs to be shown. And this is what we're doing this week. Okay? So this is what your formative is going to be like on Friday. So you can't just go from from the question to the answer without having some steps in between. Okay? If you're thinking it, write it down. Okay? So secant squared of x minus tangent squared of x. Using number 11, we could say that the secant squared of x is the tangent squared of x plus 1, then minus of x. Tangent squared of x plus 1 minus tangent squared of x is 1. Okay. Or, conversely, you could have said here secant squared of x minus, and then tangent squared of x would be secant squared of x minus 1. If you rearrange formula number 11, and then you get secant squared of x minus secant squared of x plus 1. Secant squared minus secant squared is 0, plus 1 is 1. Yep, same thing. Yep. What I'd like you to try now is, I would like you to try those two. So cosine is cosine. Tangent is sine over cosine. So that simplifies down to be, because the cosines cancel each other out. So that would simplify to be just sine of x. Yes? At home, thumbs up if we got sine of x for the first one. That's good. Good, good. Like it. Secant is 1 over cosine. Cotangent is cosine over sine. Multiply them together, and I get 1 over sine. 1 over sine is cosecant. I get cosecant there for that. Yes? Yes, sir. How would, well, like, how would you, like, oh, because I would still write it down, because then we know that, you know what I mean? The more you show, the better off you are, because it's easier for us to follow. You know what I mean? Yeah. Yeah, it's hard, because it's hard to skip steps when we're trying to read the logic that's going on in your brain. You know what I mean? So, yeah, I would write it down. Okay? All right, let's try a couple more of these. Okay? So, we could distribute first, we could simplify first, we could do many, many different things. Okay? So, cosecant here is 1 over sine. If I distribute the sine in for both, then sine times 1 over sine is 1. Sine times sine is sine squared. According to number 7, the middle one, 1 minus sine squared is cosine squared. Yeah. Somebody give me a suggestion to start number 6. At home, in person, I don't care who. I mean, give me, how would you start number 6. You could change cosecant to 1 over sine. Okay. Anything else? What else could we do right off the start? The sine squared, because it's in number 7 again. Anytime that you see a squared, it's probably somewhere on your pink sheet. Okay? And 1 minus cosine squared here is sine squared. Sine squared times 1 over sine is sine squared times 1 over sine. Sine squared divided by sine. Another way of saying it. Just sine. Yeah. Okay. Again, why don't you try these two? Maybe not. There. Give those 2. Cosecant. Well, cosecant is 1 over sine. And secant is 1 over cosine. Okay. So when we multiply or divide fractions, we flip the second one and multiply. So then that becomes cosine over sine. And cosine over sine is cotangent. Yes? Love it. Yeah. Second one, tangent squared plus 1. That is secant squared. Still times cosine squared. Secant squared is 1 over cosine squared. Cosine squared times 1 over cosine squared is 1. Questions, comments, concerns, clarifications on any of those? Yes, ma'am. As long as I can follow your logic. Yep. Because you could have multiplied in there by, you could have distributed in cosine squared times tangent squared. Well, cosine squared times tangent squared is cosine squared times sine squared over cosine squared, which is just sine squared. Cosine squared times 1 is cosine squared. So then you would have cosine squared plus cosine squared. Hammer, that's just 1. Yep. There is. I always tell kids in this unit, if I want to go from here to Mosinee, I don't have to get on the freeway. I can go out to Marathon if I want and cut in on 107 down to 153 and that way. Okay, you know what I mean? So there's more than one way to get to the end. As long as I can follow your directions to get to the end, we're good to go. Okay. We might have a little factoring action to do, a little algebraic type things. We like the algebra. Okay. So, excuse me. If I see that both terms have a sign of x in them, I can factor that out. Okay? Greatest common factoring. If I factor out a sine squared or a sine of x from sine of x, I'm left with 1. If I factor out a sine of x from sine x cosine squared x, I'm left with cosine squared of x. From there then, 1 minus cosine squared, well that's sine squared. Sine times sine squared is sine cubed. Your goal is to get a simplified version of the original question. Sometimes it'll be nice and neat. Sometimes you might have 1 or 2 trig functions in there. Okay? Sometimes it doesn't. Sometimes it's 1 step. Sometimes it's a bunch of steps. Okay? So with that being said, why don't you try factoring or solving or simplifying? I should say, can't solve. That's not till next week. Try simplifying these two. Looks like both terms have a cosine squared. That's going to leave me with 1 plus, oops, almost put cosine squared again. 1 plus tangent squared. One plus tangent squared. Number 11 says that that is secant squared. Secant squared is 1 over cosine squared. Cosine squared times 1 over cosine squared is just 1. Questions, comments, concerns, clarifications? Looks like we can factor out a sine. Would leave me with sine squared plus cosine squared. Sine squared plus cosine squared is 1. 1 times sine is sine. Okay. Now, one thing that I can tell you as you go through this, and as we get to the next section, 5.2, we're in chapter 5, by the way. We're in 5.1 right now. When we get into 5.2, we're going to say sine cubed of x plus sine of x cosine squared of x is equal to sine of x. And you're going to have to prove that. You're going to have to show, you're going to have to simplify one side and go through there. But I will tell you that you cannot be afraid to make a mistake. Okay? It is quite all right to make a mistake in this stuff. Okay? You just might have to go an extra step. Okay? Or maybe it's like you get to the end and you can't get it, and then you look back and you're like, oh, what if I did this? What if I tried this? And it takes you down a whole nother path. Okay? And that's fine. It's okay to make mistakes. Okay? It just means that you're trying. That's all that does. Okay? All right? Fractions are our friends. The last topic today when we're rewriting all this fun stuff or when we're redoing things as fractions. Okay? So way back in 6th grade, probably even before that, you found common denominators. And you said, oh, this has got to be over 15, and this has got to be over 15. And then you went back and you adjusted each fraction, and you said that, well, 3 times 5 gets me 15, so 1 times 5 is that adjustment. 5 times 3 gets me 15, so 2 times 3 is 6. And then you said that this is 11 15ths. And then you went through and you simplified that if possible. Okay? And you got that. Then fast forward a couple of years, probably more along the lines of the last year in your Algebra 2 classes. You did rational fractions. And we basically said the exact same thing. First off, you gotta find a common denominator. In this case, the common denominator is x times x plus 1. And you adjust it, and you said the first fraction is missing an x on the bottom, so you need to multiply the top by x. And so you got x there. Okay? In the second fraction, you said, oh, we're missing an x plus 1, so we got to multiply the top by x plus 1. But then you said, oh, now I can add the tops. So then this would be x plus 2x plus 2 if you distributed all over x times x plus 1. And so then in the end here you said you got 3x plus 2 over x times x plus 1. And you said, yep, that's my answer. Because I can't simplify or factor the numerator, the top of that. I'll tell it there. Okay. Well, fast forward to, 3.5 minutes ago when we opened up this slide or when we clicked onto this slide, trig is the same kind of story. So if you've got an expression that's fractional, the first thing you got to do is you got to find yourself a common denominator. In this case, the common denominator is going to be sine of theta times 1 plus cosine of theta. And then you got to go back and you got to adjust each fraction. Well, this first fraction is missing a sine of theta. So I got to multiply the top by sine of theta. Sine of theta times sine of theta is sine squared of theta. This right fraction is missing a 1 plus cosine of theta. Then you can add the tops. So if I added the tops, I would get sine squared of theta plus cosine of theta plus cosine squared of theta. And that would all be over sine of theta 1 plus cosine of theta. And then you would say to yourself, is there anything that I can simplify on the top? Anything at all. Simplify on the top. What are you thinking, Lucas?
The sine squared plus the cosine squared.
These two right here, that makes a 1. So really my top is just 1 plus cosine of theta. And then you're saying to yourself, have I simplified all the way? Or can I simplify even further? The top has a 1 plus cosine, and the bottom has a 1 plus cosine. So those get canceled out. And that leaves me with 1 over sine of theta. Well, what's 1 over sine of theta? That's cosecant. This is why I love this unit. This big, nasty, ugly fraction plus a fraction simplifies just through cosecant. Okay? So you're taking these huge things and you're simplifying, and you're doing math, and you're doing great math, and you're doing algebra, and you're loving every minute of it, and it's just cosecant. Yeah? It's good stuff. Love it. Okay? In the pink packet that you picked up today, and I believe that Group B, you got it last week, there is the first page, the Trig Identities Practice. The front side, you could be working on that for some extra practice today. You can save the back side of that one for tomorrow. We'll get to some more of those tomorrow. Okay? That's all I got for you today. Those of you playing along at home, thanks for playing. I'm good if you go. If you got questions, you can stay.